Hello, everyone, and welcome to this week's episode of Open to Public HVAC School. This is Crystal, and today we're going to cover the topic of if you are having a short in your low voltage line, but only in cooling. Now, these are common symptoms of a shorted coil in your contactor. So we're going to go over a few things you can do to do a simple diagnosis and what that looks like. You're going to need some sort of meter. For this test, you actually do not need a clamp meter. You can have a simple ohm meter. So before we get into diagnosis, I've covered this in another video on exactly what's inside of your contactor, but I went ahead and printed that out here for us. It's a good idea to understand how this works in order to properly diagnose the fact that it is potentially your contactor. On your indoor unit, you would have, and this depends on if you have a gas system or electric system, but you will have a tie-in where all your thermostat wires go. Air handlers normally have them on the outside where you'll see all your small thermostat wires, and you'll have a G, W, Y, C, and on that Y you should have two wires, which goes out to your condenser, or rather it ties in the 24 volts to call for AC. If this short is only happening in cooling, it normally has to do with this guy right here. When the thermostat calls for cooling, it's going to send a signal out to this guy right here, or if you have a heat pump, it would go to something called a defrost board. And that defrost board would then send the 24 volts to your contactor. Inside your contactor, this is what we're looking at here. Get it centered a little more for you guys. Now, you're going to have your contacts, which are these guys right here. And one of the things to do that is good while you're out there is you're going to check, in which we did go over that, check your contact points for pitting. And it's really hard to see that in here, but under there you have points right here as it's showing. You have points in there that make contact. If these are pitted, which over time they do, because they're going to have an arc, an electrical arc that comes through here each and every time your unit fires up. So you're going to get pitting here. It's going to happen. And I recommend changing these really, at the very least, every 5 years, because, just wear and tear part. It's a really good idea to keep these points clean so that you don't have to worry about future issues. Now, these are not or should not be closed until the 24 volts, the low side voltage. Once your thermostat is turned to cool, it should be sending that control voltage or low side voltage in order to pull your contactor in so that it makes contact, like so. So we're simulating the call for cooling from your thermostat. You should see when you're out there and your electrical panel is removed, if you turn it on from your thermostat and you do see this pulling in, it means you are getting your 24 volts. Therefore, the thermostat is doing what it should be doing. If it pulls in like this and nothing comes on, you have a bad contactor. Now, as we were speaking before about the shorted coil, so inside of this guy is a coil, and it's hard to see in there because this one has a fully covered coil. Now those coils, you're gonna see, if I can get a decent angle here, you can see that little small copper coil right there. And since this operates under electromagnetism, this is actually a loose or separated armature, meaning it's not going to pull closed and it's not going to energize these coils until the 24-volt line comes in. It'll pull that spring down, it'll make contact, and then the 240 volts are going to come in through without resistance here and fire that guy up. So if you have corroded or bad contacts, if you're hearing a loud buzzing or what we call chattering, like this right here, that means you're dealing with a bad contactor. So a good way to test while you're out at the unit for your low voltage short. And what I mean by a low voltage short is inside your indoor unit at your transformer, most people either have an inline fuse, a 3-amp fuse, or a 5-amp fuse. If you don't have a fuse in line and your thermostat is no longer displaying, then that means you've probably shorted your thermostat. Now, of course, there's other things we can do to check that, but most people these days do have an inline fuse, whether it's on your control board or inline on your transformer. So if you are only popping a fuse on your indoor unit during cooling, you know it has something to do in the cooling cycle, whether that is a short from the thermostat or from the contactor. So as always, we're going to make sure that our meter is set to ohms for continuity, this guy right here. And we're going to connect our leads across your contactor to first make sure that your coil is good. And then we're going to check and make sure that there is not any pitting going on in here. So with our ohm meter set to continuity, we're going to go ahead and hook our leads up to the 24-volt side first so that we can check our coil. Now they do make leads with clips on the end like these, and they're really handy to get, especially for diagnosing. And if you are a technician, I highly recommend getting some leads with the clips on the end. As we are diagnosing the contactor, we first need to make sure that our equipment is working like it should be. So with it on the continuity setting, check and make sure between your two leads, it's reading little to no resistance. Obviously, there is no resistance, so therefore, we are good to go. I'm going to use these gator clips here just so it's easier. I don't have to clip it onto the terminals here. I can just go ahead and connect them up on either side. So again, we are putting them on the coil side here as we're checking to make sure that our ohm reading is good with the coil. So now that we know our meter is good, we're going to go ahead and connect this up here. Now, on our coil or contactors, what we're looking for as far as ohms, we're going to be looking somewhere between 10 to 20 ohms, somewhere around there. If you're reading less than 1 ohm here, then that is not good. that's a sign that there is a problem. So make sure that you have somewhere between 10 to 20. So we're going to connect here. And there we have it. We're reading somewhere around 21.8. Perfectly fine. Now we know the coil is good on this one. If yours is reading less than 1, you know you have an issue. You need to replace your contactor. So that's going to be test number 1. Let's check across our poles here on connection. Now, if your unit is, say, staying on all the time, you would notice that this would be pulled in and would be stuck. There should not be continuity without the switch being pulled in. So what we're checking for here is we're checking to make sure that there is in fact no continuity from metal to metal, just for simplicity's sake. And there is no difference here when we are checking across as to where you're going to put your leads, because in this case, we're not worried about positive and negative. All right. So when I connect my lead here, it should not beep. If it does, bad contactor. All right, there we go. It's showing that it is open, which is exactly what it should be reading. Now, on these poles, okay, these are separate from your coil. So we're not looking at the readings from the coil like we did with the ohms. What we're doing here on ohms is we are looking for less resistance. So the lower the better, because obviously we need to be making good contact for your unit to be working efficiently. So when we simulate the 24 volts here and we push it in, we should be reading less than 1 ohm, which we are. So perfect. Just as an important side note, obviously when you're doing your visual inspection, make sure you don't see any evidence of melting, burning, especially if you have an exposed coil. If you see melting, and you'll know because it's going to be all dark on one line, it's going to be melted. If you see a melted coil in there, you for sure know that it is going to be a shorted or bad coil, and therefore you need to replace it. So what are some other potential reasons that your unit could be shorting in AC only? Well, your thermostat could actually either be shorted itself. Normally what I see is a wire somewhere has been nicked and it's touching, and it will short out both the thermostat and your low voltage. You'll see your fuse popped and whatnot. But if that's the case, more often than not, your thermostat will not be coming on at all. Make sure, as we've mentioned in other videos, that your thermostat is on. Make sure the batteries don't need to be changed. And when trying to locate a short, this is why it's very important to know if it's only happening in one setting or the other. If you are popping a fuse, no matter what setting you're putting that in, that's going to be a different set of diagnosis, because we're trying to look for where that short is occurring. So a shorted coil in a contactor can only be happening in residential straight cooling systems from the contactor. So if it's only happening in cooling, you are popping fuses or popping anything along that low voltage line when calling for cooling, this is more than likely your culprit. Keep in mind when you are diagnosing, sometimes you do need to go in a case-by-case situation. More often than not, if you diagnose correctly with the isolation diagnosis, it's going to rule out a lot of other things. And so that's why very first thing when you go out to your unit, you should, of course, visually inspect the part and make sure that there are no melted wires, melted coil, obvious signs of short, whereas then you're seeing charring, melted, insulation on your wires, that sort of thing, because that kind of nips it in the bud. Hey, it's definitely something going on out here, and I can visually see that. The other thing, as we were talking about, just check that with your meter, make sure everything is ohming out correctly. If your contactor is actually testing good, then we're going to be working our way to other possibilities within your system. Okay, so as far as heat pump systems, for those of you that have another potential that it could be, I'll get a photo up here for you, but this can also cause a short in your system, which is the solenoid valve on your reversing valve, or your solenoid coil rather, on your reversing valve. We're going to test this the same way we would with the contactor. Just carefully remove it, and then we're going to place our meter. And again, make sure that your meter is good and you have it on the correct setting. And we should be reading somewhere between 10 to 20 ohms. And there we go. So we know, in fact, that that is good. Or if it's reading less than 1 ohm, just like our contactor, then we know that it is the valve, the solenoid, if your contactor is reading as good. So for those of you with heat pumps, that can be another option that you can test in your outdoor unit. Hypothetically, the only thing else we could be experiencing if you are only getting a short on your cooling cycle is potentially you could have wires that have shorted together on your C and your Y, or your thermostat could actually be bad and can cause a short. So these are just food for thought on what it could be. Again, if it's only occurring in your cooling cycle and it is not your contactor. More often than not, it is. Now, we did all take a vote earlier, and rest assured, we are going to do a heat pump video on how a heat pump functions and some common issues with heat pumps. However, for now, we're just going to do this short video for people that are having shorts in their cooling. So again, don't worry, that video is coming. We are making it right now. So hopefully this has been helpful for you. And as always, if you have any questions, ask in the comments below and I will get to them as soon as possible. Thank you so much, guys, and I hope that you have a wonderful rest of your day.